All right, this first question is asking you to calculate rate of change when a is equal to 2. So you need to use this formula given in the homework set, f of x plus h minus f of x divided by h, and you're looking at the limit as h approaches 0. This is a formula that you use to calculate derivatives kind of the lengthy way. But in this case, x is going to be a. And they tell us, problem tells us that a is 2. So I am going to, actually I'm going to plug in a first and then we'll plug the 2 in. So f of a plus h, that just means you substitute a plus h anywhere you see an x. So 3 minus 4 times a plus h minus f of x, or f of a. So that's just rewriting the function with an a instead of an x. That parentheses there is very important, so it keeps your signs straight. Then all divided by h. So I could either substitute the 2 in now, or I could expand. First, 3 minus 4a minus 4h minus 3 plus 4a. I just use the distributive property here. Divided by h. So positive 3, negative 3 goes to 0. Negative 4a, positive 4a goes to 0. Now we're just left with negative 4h over h. Well, that reduces to 1, so I'm left with just negative 4. So you're going to use that method to solve the remainder of these problems that look like that. You'll do exactly the same process. In this question, you are asked to find the derivative at 1. What that's asking you is the rate of change of the function when x is 1. So if we go to this function and look at when x is 1, the rate of change is going to be whatever the rate of change of this line is. So I'm going to look for 2 points on this line that are easy to calculate. So it looks like this point and I'm trying to see here because it's not quite at 2, so I'm going to go with this point and this point. So that gives us 4 to 6, 2 over 2, so that rate of change is 1. So the answer to that would be 1. And again, you're going to want to use that method for solving other problems similar to this. Okay, so this last question is asking us to find the rate of change when x is equal to, I believe the problem said negative 4, but let's just do a different value, but just so you can still get the idea. So let's say when x is negative 3. So it says to use a graphing aid. So I went ahead and used Desmos. Let's see if that's still pulled up. It is, so that's good. Okay, I'm trying to use my clicker there and that's not working. Perfect. Okay, so I've started by plugging in ddx. So to do that, you see this keyboard here? Pull that up, go to Functions, Miscellaneous, and choose ddx. And then I put the function itself in parentheses. What this does is it graphs the derivative of x squared over x squared plus 1. So then if you're asked to evaluate any derivatives, you just go to this graph and click. When x is negative 3, the derivative is negative 0.06. So your answer would be negative 0.06. But to click on various points of interest, you just scroll right there. That one's highlighted because it's a local minimum. It's highlighted because it's a local max.